EDX Core Pure, complex numbers 3, the modulus argument and loci, converting the modulus argument to Cartesian form. So now we're going to take the modulus argument coordinates r theta and convert them into Cartesian coordinates x, y. If you look at the diagram, we can see that the x component is given by r cos theta, just using trigonometry, and the y component is given by r sin theta, just using trigonometry. And we know that z can be written as x plus iy. Useful note there to check that you are using radian mode on your calculators. So in this first example, we're given the modulus argument components for 2 pi by 3 and we want to convert to Cartesian. So it's always useful to get a quick sketch, so we can see there's the modulus 4 and the correct argument 2 pi by 3 from the positive real axis. We know that x can be found by r cos theta. So x can be found by the modulus 4 times cos of 2 pi by 3, which is the argument for this complex number. And when we work that out, we get x is 4 times minus a half, x is minus 2. And we would expect a negative x coordinate on the diagram here. So that's a useful little check. If we're looking for the y coordinate now, we know that y is r sin theta. So y is 4 sine 2 pi by 3. Y is 4 times root 3 over 2. So y is 2 root 3. And we would expect again from the diagram a positive y coordinate there. So now we know that z can be written as minus 2 plus 2 root 3 I. So it's back to Cartesian form. And there's a full method for you to check as well. So in the second example, we've been given the modulus argument form of the complex number and we want to convert it into Cartesian form. You can see from the very useful sketch, we can see the modulus is root 3 and the argument is minus pi by 3. So just for clarity, I'm just going to expand this bracket so we can see what's happening here. So we've got z is root 3 cos minus pi by 3 plus I root 3 sine minus pi by 3. And we know that this component here must be x and this component must be y. I'm going to do them separately just so you can see exactly what's happening. But you could do them together. So x is root 3 cos minus pi by 3. So x is root 3 times a half, which is root 3 over 2. And y is root 3 sine minus pi by 3. So y is root 3 times minus root 3 over 2, which is minus 3 over 2. So we've got the x component, we've got the y component, so we can bring them together now to write down z in Cartesian form. So z must be the x component and then the y component, and don't forget the I. You can see the full working on that slide. In the next session we're going to be multiplying in modulus argument form.